Hello everybody and welcome back to Unit 8 of Regents Chemistry where we are talking about reactions and stoichiometry. Today we will dive into stoichiometry. You guys will learn how to perform different stoichiometry calculations using the mole ratios. Okay, so stoichiometry basically is the relationship between the reactants and the products whenever we are looking at a chemical reaction. Now notice the word quantitative relationship. Remember how in the very beginning of the school year when we were differentiating between quantitative measurements and qualitative measurements. We said when something is quantitative, that is when we are talking about the numbers. So in this case, when we are saying that it's a quantitative relationship, then that means we are talking about the number of reactants and products that we have in a chemical reaction. So let's say this is the chemical reaction that we're looking at. If you notice the ratio between the reactants and the products, the different reactants, the different products that we have in here, that thing is called the mole ratio. We'll talk more about that in just a second, but that's basically the bottom line of stoichiometry. So what stoichiometry says is that if we change because of that ratio that we have in between the reactants and the products in a chemical reaction, remember how we were balancing the equation, so that balance and that ratio has to stay the same. And because of that, if we change one quantity, we have to change the other quantity so that overall the reaction remains the same. So if you are taking 2 moles of water, that has to react with 1 mole of oxygen gas only. So so if let's say you increase the moles of oxygen gas to 2 moles rather than 1 mole, we need more hydrogen as well to react with that. So in this case, now we'll have 4 moles of hydrogen that are going to react with 2 moles of oxygen. So that's what stoichiometry tells us, that if one thing changes, the other thing has to change as well, so that overall the reaction remains the same. So before we dive deeper into what the calculations look like with stoichiometry, there are two very important things that you need to know about stoichiometry in order to do those calculations. And you kind of know both of those things. So the first thing is the molar mass, which we already know. We discussed that in topic 8.3. And remember, whenever we have to convert, we are given the grams of something and we have to convert that to moles. We use this relationship right here, which is also given in table T. The number of moles of anything is equal to the given mass, and we divide that by the molar mass of that thing, or the gram formula mass. And if we are given the moles of something and we want to convert that to the grams, we use the same equation. We do the cross multiplication, and this is the new equation that we get. The mass of anything is equal to its given number of moles, and we multiply that with the molar mass of that thing. And then the second very important thing that you need to know about stoichiometry is the mole ratio, which we briefly talked about just a few minutes ago. So if let's say this is the same equation that we looked at before, this is the equation that we are talking about, and we are trying to determine the mole ratio between different reactants and products in this thing. Let's start by looking at the mole ratio of hydrogen gas and oxygen gas, which means how many moles of hydrogen gas are reacting with how many moles of oxygen gas, and that is basically the mole ratio. So if you look at the equation, you'll notice that we have 2 moles of hydrogen that are reacting with 1 mole of oxygen. So that is the mole ratio. So if you like cancel out the extra stuff, 2 over 1, you'll get a mole ratio of 2, which you don't normally always have to do. We use the first part, the 2 moles of hydrogen. For every 2 moles of hydrogen, we use 1 mole of oxygen. Now, if let's say we are trying to find the mole ratio of hydrogen and water, same thing, look at your equation, and the equation tells you that for 2 moles of hydrogen, we are getting in the product 2 moles of water. So overall, the ratio 2 over 2 is equal to 1. And then finally, if let's say we are trying to find the mole ratio of oxygen and water, we do the same thing. For every 1 mole of oxygen that we see in the reactant, we get 2 moles of water as a product. So how do you calculate the number of moles? Just looking at the numbers, the coefficients that we have with the symbol or the formula of the compound. So in the last case, the ratio will be 1/2 or 0.5. So that's the mole ratio, super important thing to remember for any type of stoichiometric calculations. Now there are two different types of stoichiometric problems that you can get. The first type of problems are the mole-mole problems, which means the question might be asking you that if you are given this number of moles of a compound, how many moles of the other compound are going to react with this? For example, here you're given an equation and the question is asking how many moles of calcium are needed to react completely with 6 moles of water in this reaction. Now, the first thing that you want to do is make your equation simpler. So you want to cancel out the things that you don't need. So in this case, because the question is only concerned about calcium and water, we can go ahead and cancel out these two things in the product because we are not talking about them, so we don't even need to look at them. The next thing that we want to do is figure out the mole ratio, which means how many moles of, for every 1 mole of calcium or 2 moles of calcium or whatever it is, what's the mole ratio that we are given in the equation. So in this case, we have for every 1 mole of calcium, it's reacting with 2 moles of water. And we didn't do anything to figure that out. It's given right in the equation. All we did was looked at the coefficients. The coefficient of calcium is 1 because there's no number there, so it's just 1. And then the coefficient of water is 2. So 1 mole of calcium is reacting with 2 moles of water. There we have the mole ratio. Now the next thing that we want to do is set up the proportion. So mole-mole problems are quite simpler because all you have to do is you start with the given number of moles of, let's say, whatever that compound is, you call that compound number 1. You start with those given moles and you multiply that with a mole ratio. You do definitely want to take care that you put the moles of the other thing on the top and the moles of the first thing at the bottom just so you can cancel them out. And this is what we mean by that. So in this case, we are given the moles of the water. So we start with that. We have 6 moles of water and we multiply that with the mole ratio. Now, when I am multiplying this with the mole ratio, I want to make sure that I write 1 mole of calcium at the top because that's what I need my answer in. The question is asking for the moles of calcium, so I want my answer in moles of calcium. So I want to put that on the top and then I put the 2 moles of water at the bottom. Once again, where did I get those 1 mole of calcium and 2 moles of water from? From the mole ratio that we figured out using the equation. Now what we can do is cancel out the mole of water with the mole of water, only the units, not the numbers. We are not canceling out the numbers. The numbers are staying because now we want to do the math. So 6 times 1 will be 6 divided by 2, that is 3. So the answer will be 3 moles of calcium. So those are your mole problems. The second type of problems that we can get are the mass problems. So in this type of question, they will be asking, instead of moles, they'll be asking if you are given this number of grams of the first element, how many grams of the second element are going to react with this, or something of that sort. For example, the same question again, but in this case, they have given us the grams of water and they are saying how many grams of calcium are going to react with that. So we'll do the first 2 steps exactly the same way as we did them in the first step. So, I mean in the mole problems. So we'll go ahead and cancel out the things that we don't need. So the question is only concerned with calcium and water, so we'll keep those 2 and cancel out the other 2 things. Then we want to figure out the mole ratio, which is still the same. 1 mole of calcium is reacting with 2 moles of water. And then we want to set up the proportion. Now here's the thing. In the question, we are given the grams of water. There is absolutely no way for us to go from grams of water to grams of calcium in one single step. So this one is a bit more complicated, but please stay with me, follow all the steps, and you guys will get it. So we need to do a couple of steps to go from grams of water to grams of calcium. So first of all, we'll start with the grams of water that are given, which is 108 grams. And then we'll convert this to the moles of water so that we can multiply that with the mole ratio. Now, remember how we were using that equation to go from grams to moles? We said if we are given the grams of something and we want to find the number of moles, then we basically just multiply that with the with the molar mass. So the molar mass of water, you guys know how to find the molar mass. We have we have two hydrogens, so we multiply 2 with the mass of hydrogen, which is 1, and then the mass of oxygen is 16, and we only have 1 oxygen there. So 16 plus 2, we get 18 grams per mole for the molar mass of water. Now, when we are writing that using the dimensional analysis method, out of the mole and the gram, we want to cancel out the grams with this gram of water, and we want to keep the mole at the top. So we'll say that 1 mole of water has 18 grams of water. Because remember, your molar mass is in grams per mole, which means you have 18 grams in 1 mole. So we'll put the 1 mole at the top and we'll put the 18 grams at the bottom. Now the grams of water are going to cancel out with the grams of water. And we'll not do the find the answer yet, because at this point we only have the moles of water, which is not what we want to get in the final answer. So the next step would be to multiply this with the molar ratio so that we can get the moles of calcium, because eventually we want to get to calcium. We do not want to stay with water. So we multiply this with the mole ratio. And remember, when we are writing the mole ratio, because the moles of water are on the top, so we want to put it at the bottom on the other side and the moles of calcium at the top so that we can cancel out the moles of water with the moles of water. Now, at this point in our answer, we'll have the mole of calcium. So the next thing that we'd want to do is multiply this with the molar mass of calcium. Now, when we multiply this with the molar mass of calcium, definitely will, because that's how we convert moles to grams, definitely will get our final answer in grams. So the moles of calcium will be, if you go to your periodic table, you look up the atomic mass of calcium, that turns out to be 40. So 40 grams of calcium are in 1 mole of calcium, because calcium has a mass of 40 grams per mole. So now we can go ahead and cancel out the mole of calcium with mole of calcium. And at this point, you can do your math. Because we have canceled out all the unnecessary units already, so the only unit that is left in this case is grams of calcium. So that's what our final answer is going to have. But please take care of all of the numbers. So we'll have 108 times 1 times 1 times 40 at the top. And then at the bottom, we'll have 18 times 2 times 1. Now plug this in your calculator, and your final answer turns out to be 120 grams of calcium. Now, I know this was a lot of steps, so if you are confused on any part, please go back, start this question all over again, and make sure that you watch this again so that you absolutely understand how did we get to the final answer. Alrighty? And that was it for this part, guys. Take care. I'll see you in the next one.